Well, we found that some of our companies are well underway in this process of establishing Industry 4.0 and automation projects, while others still lag behind. So it's now up to us to help these guys make sense of all these terms that are mingled up under the Industry 4.0 concept.
Kia ora, I'm Troy, HERA CEO, and welcome to Stirring the Pot. Thanks for connecting. If you're new, here's what you can expect. We're going to be talking the tough stuff, the things that keep us metalheads up at night. There are many challenges facing our industry and equally many opinions on how we should tackle them. Stirring the Pot provides a facilitated forum to discuss and challenge these viewpoints. So let's get to the nuts and bolts of it. Today our conversation is with our very own welding engineer, Holger and Jan Polzer, an automation engineer and Industry 4.0 specialist with the University of Auckland. Holger has recently spent time at the Intelligent Fabrication facility in Australia to gain hands-on experience in smart scanning and printing, virtual reality-assisted fabrication planning and more. Insights we hope to share with our membership. Let's start with the basics. What is Industry 4.0?
From my point of view, Industry 4.0 is a consequent further development of all the model-based automation approaches of the last decade. Though therefore the models have been further developed to some sort of digital twins, which means they've got some further capabilities in terms of autonomous communication and decision making. And this allows the inclusion of further decentral optimization concepts in addition to the old-fashioned way where it's centralized optimization. The benefits why we do that is that it allows us better quality, better process control, but further on smarter products and also an improved customer relationship, customer experience. This needs some enabling technologies. Basic examples are IoT, cyber-physical system, big data, augmented, virtual reality. Cybersecurity is an issue which is coming up then, just to mention some of them.
And how does it differ from Industry 3.0, Industry 2.0 and Industry 1.0?
Yeah, 3.0. So that started mainly, let's say in the 70s when computers are used for process optimization. Second industrial revolution is mainly through electricity, mass production in factories. And as first industrial revolution, usually the invention of steam engine is mentioned.
And Holger, why is Industry 4.0 important for HERA members?
Well, let's start with automation. I think automation is happening at the moment at a great speed. And for company, automation has a range of general benefits: better product quality, higher repeatability, increased productivity. And it's also a way to combat the shortage of skilled labor. Now, these advantages are usually coming to the forefront for larger production volumes. Now, our task here is to make these available for the typical New Zealand fabricator, which runs smaller production runs and requires higher customization. And Industry 4 is the add-on to this automation, where we integrate all these machines and then are able to reap the benefits of this integration.
Yeah, maybe I'd add that point. That's completely right. Especially for smaller customers, it gives them also the chance to make their products a bit smarter. Thinking about how to introduce further sensors which allow an additional insight in the process where their product is maybe placed in. Sensors which allow maybe also a part of self-diagnostic. So it's for an SME, it's not only important to deliver the whole big picture, it's maybe also an interesting part to be part of it and to establish their products in a way that their product is able to communicate with a bigger plant and deliver some further insight and information to the overall process optimization.
Jan, so you have worked in Industry 4.0 in Germany, and specifically with the metals industry.
Yeah.
What is it being used for, and what can you give us as case studies from your experience there?
Yeah, Industry 4.0 is a big topic there, and so it's used for process optimization, also for customer relationships. in terms of process optimization, it's not always possible to foresee all the environment conditions, and therefore it's very helpful if you've got some decentral intelligence decisions. So you've got an digital twin of your product where some models can be included. It's got the ability to communicate with other subsequent process parts. So process settings can be optimized then with these local decisions. So the product is telling the machine how to process it in the best way and not the other way around. And I've got some examples which are really exciting, where it's really easy understandable why this concept can be so powerful. And why it's much better, I would say, as an extension of the existing system. And customer relationship is also different then. It allows you much more interaction, and customers can, in steel industry, for example, change their order quite long. So it's not only putting one order and then it's done. So it's quite flexible because the background with Industry 4.0 allows you a more flexible way of your production.
Mm-hmm. In terms of the production process and the metals industry in Germany, who are the leaders in steel manufacturing that are using Industry 4.0?
I would say almost all of the big plant suppliers like Sundvik, Andrix, SMS have that in their mind and in their portfolio. The Applied Research Institute where I worked at the BFI in Germany is strongly involved in that and bringing these principal ideas on the road at the plant. Though Fraunhofer is working also in that area. So there are a couple of players who are investigating these approaches, building up new equipment which is able for these more connected integration. So the overall vision in Industry 4.0 is so the linkage of all horizontal and vertical processing stages. And so that needs communication across the production. And there are a lot of drawbacks at the moment. So also, as Germany is working hard on this point, there are a lot of plants where still work must be done in this point.
Mm-hmm. And can you give us a specific example of where someone has actually used Industry 4.0 to solve a problem within production?
Yeah. For example, I had a project with a hot strip mill. So there, the bottleneck was the pickling line. And the question was how to improve that. And in the brainstorming, it turned out that if the coils would arrive warm in that pickling line, let me say, as introduction, 2 words. You roll a slab and then you've got a coil, maybe 680 degrees, and this will be cooled down to room temperature, a scale going, and this scale is removed in a pickling line. So usually these coils arrive cold at the pickling line, and you can improve throughput of this next processing stage if the coils arrive hot. So we need some sort of intelligence which adapts this cooling process based on the actual load of the plant. And we did that by creating a digital twin, which is born after the coil left the hot strip mill. And this twin asks himself autonomously the next processing stage, the pickling line, when are you going to process me? So there's also a model and agent digital twin running, calculating the stock, which is already has checked in. And he's giving back, in 18 hours, I can process you. Now then, this twin knows, in 18 hours, I would like to have 80 degrees. At the moment, I have 680 degrees. It's got a model available, which calculates cooling down with water and with air. And then it's checking the outside temperature, seeing, 10 degrees outside at the moment. So that means only 5 hours water cooling instead of the standard 8 hours water cooling. Because then the rest of the time I will be outside at 10 degrees. Though this twin is telling the next machine, the coil shower, how to process it in the best way. So as a result, the coil arrives warm at the plant. And now again, models tell the machine, first of all, I'm warm. And I'm not equally warm about the length. So this coil is still giving the pickling line offsets in terms of additionally meter per minute, how it can be driven faster. So again, the product is doing the fine setup, the fine tuning for the process control. And as a result, we've got a big improvement in terms of throughput, but also additionally benefits which have not been foreseen. For example, there are some steel grades which are nasty, tend to strip breaks when they are cold. Now the coils arrive warm, and we've got plenty of opportunities, plenty of situations where normally a strip break would have occurred, which leads to several hours of downtime of the plant, and which can be avoided just because the material is much smoother at 80 degrees arriving time.
And I'm assuming that the steel manufacturers tend to have a lot more turnover and therefore money to invest in creating digital twins than probably the companies further down the channel. How easy is it to create a digital twin?
I think it's not that complicated. For sure, there's some work which must be done. Most companies have already first thought about modeling. And the idea in this digital twin is to include these models which are relevant for your production process. For example, in terms of quality or in terms of parameters which are hard to measure, like internal stresses, temperature distribution, whatever is relevant for your process. You need a material tracking, first of all. That's maybe a bit work, really, because several companies do not have that. Once you've got the material tracking, then you can implement a framework for digital twin. We at university, for example, developing just such a framework at the moment. And then you can collect all your process data additionally to your digital twin. And the big advantage is that you've got now all your process data in one position for your product. That means in the end, if you've got a quality issue, you said these 5 pieces have got a quality problem, you press on a button and within seconds you've got all the process signals which are related only to these 5 bad pieces. Normally it would take an engineer weeks of work to collect all these process signals which are only related to the bad pieces. So it's a very big advantage in terms of quality and process optimization to collect all these parts. Back to your question, you need tracking of your material, of your production, and you need some IT infrastructure to implement this sort of digital twin.
Mm-hmm. And Holger, you have spent a bit of time just recently at the Intelligent Fabrication facility at University of Wollongong in Australia. What is happening there that would be relevant to this topic and our members?
As far as I can see, the guys in Wollongong, they focus at the moment on automation of welding processes. So they do feasibility studies for companies to see whether a part can be welded by a robot, what the consequences are of automating a process, what type of robot is required. So they are at the moment mainly focusing on the automation bit. I think they have something in the pipeline for Industry 4.0, but it's not yet a service they offer.
And so we do talk about Welding 4.0. What is Welding 4.0?
So Welding 4.0 is what the welding equipment suppliers at the moment use this term to bring the Industry 4.0 or break it down for the welding part. So that's acquisitioning the data that is generated during the welding process, storing this data, making this available to the welding supervisor, getting shorter feedback loops, storing the data for quality-related purposes. So it's all further enhancing the quality systems that are already in place around the welding of these components.
Mm-hmm. And at the end of last year, you did a trial of some productivity and automation audits or assessments. How did they go and what were the findings there?
Oh, we had a great range of companies from our membership taking part in this automation productivity assessment audits. So we had guests from the University of Wollongong visiting us, and we went with them to these companies to look at their fabrication facilities, especially around productivity, automation, and to some degree the Industry 4.0 aspects. Well, we found that some of our companies are well underway in this process of establishing Industry 4.0 and automation projects, while others still lag behind. So it's now up to us to help these guys make sense of all these terms that are mingled up under the Industry 4.0 concept, to help them evaluate what is of benefit to them, maybe to identify the low-hanging fruits of what is easy to achieve, what brings the greatest benefit, and help them in realizing the benefits that are promised by these new concepts.
And we have definitely started to think about how HERA can support members more in adoption of Industry 4.0. What is it specifically that we're doing, for example, in the area of research and development?
So at the moment, we need to establish for ourselves what the status is. So we had these 7 companies taking part in our initial audits. So we're looking for more companies to take part, which we can audit. So we get a better picture of what is happening. It's all part of our bigger research project around productivity. So the aim overall is to increase productivity for our members.
And what about the project that's running with the University of Auckland?
Yeah, we've recently partnered with the Auckland University on a couple of research projects. So we've got our PhD student who's working for us, helping us establishing this roadmap, making sense of the Industry 4 concept for our members, developing a tool set on how to identify opportunities. We have got 2 further research projects with undergraduate students working around the NDT and data handover around NDT. And then we want to develop the HERA workshop into a model workshop. And we're looking at what sensors are available, where the gaps are, and how we get there. And then use the students to develop the HERA workshop into a model workshop for Industry 4.0.
Okay. And do you want to talk a little bit more about what HERA is planning also in the education and demonstration area?
Yes, as part of this project, we've also started improving the overall workshop at HERA. So we're looking at adding a welding robot, which we then will be using for further research projects, maybe into 3D printing, repeatability, improving quality systems. Again, making this a demonstration workshop for industry, where we can show industry the benefits and teach them what skills are required to work this equipment.
Jan, maybe if we move over to you, just to look at the research project from your perspective in terms of engagement with HERA, how are you seeing that project being formulated and benefiting industry?
I think it's very interesting. My overall personal vision is to have gotten a quality observer in the end, which can deliver you in real time warnings and alarms when your welding started to leaving the desired parameters and the desired quality. For sure, there is a lot of research which must be done, because it's not that easy to determine online and in real time what a good weld is and what not. So our students are looking also which are maybe suitable sensors you could or you should further implement at the welding. It could be thermal cameras or whatever. And so there will be a first demonstration there. Again, the overall aim is to have some sort of digital twin of the welding process with some models inside, which can give you then these real-time warnings that something is going wrong, and so immediately you can stop or change your parameters. Maybe it's about sensors, about the positioning of your welding tool, though that's a wide area, I think, where further research should be done. At the moment, it depends very strong that you've got really skilled welders to do a good job. For sure, they are there. In terms of security-related devices, it would be nicer to have a better supervision and monitoring of that welding to ensure a stronger, more in the direction of 100% testing of all welds which are done.
Mm-hmm. So is the idea that the productivity would be improved because you're getting the real-time feedback, and also there would be a productivity improvement in terms of you would get a bit of an audit of how the welding is being performed real time?
Yeah, it will increase productivity in terms that maybe there will be less rework. Maybe the bigger benefit is ensure that you've got high quality welds. it's going in the direction of 100% monitoring of all welds. At the moment, it's more a statistical test of some welds, because there's no way of testing all welds at the moment. So quality will be an issue, and that's good for all parts you create.
Yeah, I think I like to add some words there around welding. So at the moment, welding quality is ensured by preparing samples, testing them beforehand, and then testing the welds afterwards. Because there's very little you can do currently to assure the quality during the weld. So if this would work out, this would be really quite a step forward, that you get online and real-time feedback on the quality of the weld. And if that works out, there might be quite some changes coming to welding.
Yeah, but to be honest, these are not low-hanging fruits. So there's really a long way which must be gone.
And Holger, so we have created a new cluster, an automation and Industry 4.0 cluster. Tell us a bit more about that.
The idea of the innovation cluster is to bring our companies together, get them to share stories about successes they had with automation, with Industry 4.0, and share stories we have heard. Get feedback on our roadmap process, get insights from industry, and give some feedback to industry to inform them of their next steps, to help them identify low-hanging fruits, and also for us to identify teaching requirements or training requirements for the future.
Mm-hmm. And will there be an opportunity for them to get exposure to best practice and experts who are leading in that area as well?
Yeah, of course, as part of the cluster, we try to invite guest speakers that are experts in the field to present new ideas and to share their stories, and then have a discussion following on from this.
Mm-hmm. And what would you see, this is a question for either of you, what would you see as the big leading trends in Industry 4.0 that we should be keeping an eye on?
So there will be a lot of communication where customers realize that there are changes. So let's say these so-called digital champions who really go forward in that part in Industry 4.0, they will be able to provide new customer services, more customization. They will be able to produce more flexible. This from the customer side. If you're delivering parts, there will be more and more in demand from the bigger plant manufacturers that your parts are somehow Industry 4.0 compatible. Also, this is not well defined. It means that your parts are able to communicate, are maybe able to do some sort of self-diagnostics, to raise the hand, hello, something is going wrong inside in my sensor, in my actuator, to be included in the big part of the process supervision that somewhere a flag is going on saying, so this valve is just going down, or maybe in one day it will go down, so maintenance can be planned. Augmented reality is a big trend. It's very helpful in terms of maintenance. For example, if you're building up machines and install them to China or Malaysia, and then there are some troubles, with this augmented reality, it's very powerful to assist locally engineers and technicians to repair that machine without the need to send an expert from you fly down to Malaysia. So you will see more and more competitors who offer that service, and they can offer that service for a much lower price compared maybe to you, who's not aware of doing that and who has got the need to send somebody in person to Malaysia. So you will face the situation that your competitors are able to do that services where you maybe struggle. Well, that's why I think it's a good point to think about how to include that into your product, in your production, because it makes it more efficient, more flexible. Also, it needs some investments in IT infrastructure and tracking in the beginning.
So Holger, did you have anything to add from the HERA perspective?
Yeah, I think it's important to our members to not just jump on the bandwagon for the bandwagon's sake, but to select for them what technology brings them the benefits, what increases their productivity. Select the technologies and then build on small successes.
And what are the future impacts of Industry 4.0 that our members should be really aware of, Holger?
Like, I think the danger is if people don't observe what is happening, they might get left behind with increased productivity elsewhere, cheaper products. So it's worth for our companies to keep an eye on what is happening, talk to us, talk to each other, be part of our innovation cluster, so they're not missing the bandwagon and the new technologies. Bring on board what's required. Make your company future-proof.
Thanks, Jan and Holger.
Thank you.
So there you go. Thanks for joining our conversation with Holger and Jan today. If you'd like to connect more with them, their details are in the show notes. The Automation and Industry 4.0 cluster is part of our commitment to future-proofing our industry. We are also planning to upgrade our welding centre to include robotics and Industry 4.0 capabilities for research, demonstration and education purposes. After all, as Abraham Lincoln once said, the best way to predict your future is to create it. Food for thought till we meet next time. So hit subscribe, and if you liked what you heard today, please like, review or share with any metalheads you know. Let's spread the word.